Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the sum of subarray minimums problem. Given an array of integers r, find the sum of min b where b ranges over every contiguous subarray of r. Since the answer may be large, return the answer modulo 10 to the 9 plus 7. So if we have 3, 1, 2, 4, the output is 17. All of the subarrays are, well, there's the singleton subarrays, 3, 1, 2, 4. Then there's the two subarrays, 3, 1, 1, 2, 2, 4. Then there's the three subarrays, 3, 1, 2, 1, 2, 4. And then there's the four subarray, 3, 1, 2, 4. The minimums of those are 3, 1, 2, 4, 1, 1, 2, 1, 1, 1, which looks to match what they have there, and if you add all those up you get 17. And if you do the same thing here, that's going to be 11 plus 81 plus 94 plus 43 plus 3 plus 11 plus 81 plus 43 plus 3 plus 11 plus 43 plus 3 plus 11 plus 3 plus 3, and I assume that adds to 444. I was going to say I don't know how to do it. Now that's not entirely fair. I do know how to do it in the sense that the very pure this is the definition, so all I need to do is generate every possible subarray, take the min, and then add those up. But I'm just trying to think if there's another way to do it efficiently. So my gut instinct says try something like dynamic programming. But I'm not sure there's much in the way of sub-problems here. So for example, this array, if we try to solve it just for the first 4, we'd get a significantly larger sum, I suspect. Because this 3 wouldn't be chopping down all of the subarrays involving these large digits. So there isn't a sub-problem here. And that makes it really difficult to solve, actually. Deathly silence as I stare at this and go, I don't know. I think we're just going to have to do this the hard way. So for start and range len r minus 1, for end and range start plus 1 len r. Basically this is going to give us the start and end indices of every subarray. So this is going to tell us 0 to 1, and then 0 to 2, and then 0 to 3, and then 0 to 4. And then 1 to 2, 1 to 2, 1 to 3, 1 to 4. So this is half open. So hang on. Let's actually just print this. Start, end. In fact, we'll do slightly better. We'll do the array sliced from start to end, just to show you what I mean. So I've set up end here so that the slicing works nicely. Obviously this is not going to pass the tests. This is just for me to show you what we've got. So we see we have 3. Ooh, that's not enough at all. Oh, sorry, that needs to go to a +1 because we do want to start at the last item. That looks better. we've got the 3, the 1, the 2, and the 4. Then we have the 3, 1, the 1, 2, and the 2, 4. Then we have the 3, 1, 2, and the 1, 2, 4, and then the 3, 1, 2, 4. Now, obviously, those are all wildly out of order. But it doesn't really matter, because we're going to be summing up the minimums anyway, and summing is commutative and dissociative, so it doesn't matter what order you actually add things up, as long as you add up the same set of numbers. So let's do the total is equal to 0, and then it's going to be total plus equals the total plus the minimum of that slice modulo, what is it, 10 to the power, let's just call it m, and I'll compute it out the front. M is equal to 10 to the power of 9 plus 7. If I run that, I suspect that will work. Yes, use all the example test cases. Now I worry here, excuse me a moment, Leetcode is bugging out again. If I use all the example test cases, I suspect this will be, well, I suspect it'll be too slow. I have no idea how fast this is expected to be. So one thing I'm a little bit scared of is this. This might be a copy. Well, let me put that another way. Naively, this definitely is a copy. It's creating a copy of this chunk of array to pass into min. That could be too expensive. Well, that will be too expensive if that's what's actually happening, because we end up with this quadratic thing, order n within it, that's n cubed. Actually, no, the minimum is always going to be that, but it's just this copy itself, moving memory around is slow. I don't know. Let's submit it, see if it's too slow. It's looking too slow. Yeah. So let's copy this and stick it in here. Check it is definitely too slow. It should be. Question is, can we do better? And I suspect we can, because here start isn't moving terribly often. So let's do min so far is equal to r of start. Min so far is equal to min of min so far r end. So what did I do here? Basically what I did is I said, well, at the beginning, when it's a window of size 1, then the minimum thing we've seen so far is the thing at the start. Basically, that's just a start condition, because this one here is going to do exactly the same thing. When the window is of size 1, no, actually here, n, I want to do this n minus 1, don't I? Point remains. This first one here is going to be the same as this. So that first round is going to be a no-op. On the second round, we'll have kept track. Let's go back to an example here. Let's say my window was 3. So the min so far was 3. So the first round, I'm going to add that. Then the window is going to grow to be the 3, 1. 1 is now the minimum seen so far. So the total is going to increment by a 1. 3, 1, 2. Min so far actually doesn't change. It stays as 1. So this window doesn't. So this gets added a 1 again, and 3, 1, 2, 4 again. It doesn't change. So that helps us out. So what that does is basically it removes an order n operation we had in the middle here. This is between two single elements. So this is order 1. So we've got an n squared now rather than an n cubed algorithm. Let's see if that helped. Removing entire, yeah, that helped. Removing entire order of n did wonders, surprisingly enough. Right, let's submit again. See if we do any better. If we need to go faster, I'm really going to struggle for ideas. Still too slow. This is a huge case. Okay, how can we go faster? What we could do somehow is basically sort these so yeah, what I want to do I don't know what I want to do. How can I remove one of these loops or make it log sized? So for example, when I'm looking at the 1, I need to know how many windows it will be the minimum element of. I know it's going to be minimum element of 1, 2, 3, 4, 5, 6 sets. 1, 2, 3, 4, 5, 6. Yeah. So the 1 is the minimum of six subarrays. Can I know that in advance? Or compute that more quickly? Well, hang on. How many subarrays are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 because that's 5 times 4 is 20 divided by 2. That's the triangular number of 4. Hang on, what is that? Yeah, 4. The triangular number of 4 is 10. I thought it was 20. No, I got myself. I lost my divide by 2. This one here. Do I know? Well, this... It's suspicious that that takes up 6, which is the triangular number of 3. But is there any reason for that? Well, actually, no, wherever this 1 lives, it's going to be the minimum element of... If it was here, 1, 2, 3... Oh, it would only be the minimum of 4 elements. The four of these sums. So each of these has the potential to be the minimum for up to some number. But I don't know how many they overlap as well. I was going to say, well, then I could just greedily take them. But in theory, this 2 would be the minimum of 1, 2, 3, 4, 5, 6. But 6 have already been claimed by the 1, so that's no help. 3, 1, 2, 4. Can I do something else? If I know where I'm starting, let's say, so I'm starting here. Three, 3, 1, 3, 1, 2, 3, 1, 2, 4. How can I don't think I can get this down to an order n, because I need to do something beyond looking at each of these, and I don't think I can do it in constant time. But maybe I can do it in log time. How can I work out the nearest, well, how far away so hang on, 1, 2, 3, 4. So the first one's a bit special in that it's going to be part of n groups. 1, 2, 3, 4. The last one will be the same by symmetry. 1, 2, 3, 4. These two are part of 6. N times n plus 1 divided by 2. How many is the 94 part of? 1, 2, 3, 4, 5, 6, 7, 8, 9? No, that doesn't seem right. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is right. So how does that relate to a 5? So this will be part of 5. This will be part of... I need to write this down. I'm not quite understanding something here. N equals 5. 0 will be in 5 things. 1 will be in... I don't know yet. 2 was in 9. 3 will be in the same in whatever is 1 is in. 4 will be in 5. So you are in 1, 2, 3, 4, 5, 6, 7, 8. Well, first off, do these add to 15? No. But that's expected. There's a lot of double counting, I guess. How many sets are there? There should be 20 sets. What do these add to? 10, 26, 35. Don't know anything about number 35. No, I'm going down a dead end here, I think. Counting these sets they occur in doesn't seem to be helping me very much. So when I look at this element, I know it's going to be the minimum in exactly one set because it bumps into this guy immediately. This is going to be the minimum in everything around it. This is going to be the minimum in everything after it. And this is only going to be the minimum in its own thing. Is that the way to look at this? So this guy, because it's... How can I know how many elements he's going to be, how many arrays he's going to be in? He's in 1, 2, 3, 4, 5, 6. I don't know where that number comes from. That's the problem. He's missing a 3 set there. Is one way to look at that. So he kind of should be in 7, but he's too close to the edge. This one is going to be in every set after it. So for something of size 2, that's going to mean 1, 2 sets. He's going to be the minimum. That's correct. He occurs twice. He occurs once. So there's some distance in each direction that it's bounded by. What is it? That's only going to be in one thing because it hits something smaller than itself. This never hits anything smaller than itself. So 1. 1. 1, 2, 3, 4, 5, 6. This one, well, it can't extend that way, so it's in 1, 2. And this one can't extend, so it's in 1. I have the shape of an idea here. I know I'm not being very clear, but I don't know how to get through it. Okay. Hang on. For element in range len r. Min before is equal to 0 times len r. So the min before the thing at index 0, hang on, Let's quickly enumerate this thing. Oh, no, it is an enumeration, sorry. For I in, hang on. Let me just turn all of this off. No, what I actually want here is list range len I. No, what is it I want here? Maybe I need to do some motorbikes. Maybe I need to do some pre-processing here and sort of sort out, well, there's... No, I need a min before and a min after, don't I? If I can find... I really just need to bound it. This thing, the minimum before it, and it doesn't really matter, does it? Well, yeah, it does a little bit. Min before I. No, I want to go back to making this 0 times len r, and I want to make this len r minus 1 times len r. So if I'm looking at this at index 0, well, skip it. If I'm looking at index 1, is the hang on. Hang on. So if I'm looking at this here. If Ri minus 1 is greater than Ri, let's go with J equals I. So I think I want to do some skipping here. So J is equal to R. No, this is what do I want to do with this? J is equal to R minus I minus 1. No. I want to do the min before of J. No, that's not correct either. Okay, I need to do some. How do I want to start this? Should initially point to itself. No, it shouldn't. I need to look. And that's the easy one to do. But I need to do some skipping because I know this 3. Well, no, I know this. What the heck, that'll do. That itself is quadratic, though. That's bad. That's terrible. There's skipping logic here. My brain, Friday night, isn't able, apparently, to do this. if I'm looking at the 4, if I know the min before this is here, I know that when I look at this, I can actually skip all the way back to here. So J is actually min before J. So maybe this is J plus 1 here? No, not 1 plus 1. Okay, so we're starting here. J is looking here. While this thing is greater than array I, let's go with new. If new is equal to J, break. J equals new. Right, so that just handles that. So we go here, we go to the 0, and then we get into a little loop of zeros, so we break out. We go here, we look before it, we stop. For we look here, we see its min before is here. That would actually tell us to go there, wouldn't it? So that's actually not quite right. We wanted to stop there. Well, no, actually, we wanted to stop there. No, hang on, what am I doing? What am I doing? We're looking at the 4. The min before, while Rj is greater. Well, that's not true. That we just stop. So this isn't min before, this is kind of max before, but anyway. No, it's not. It's sort of the closest lower thing. Oh, whatever. I've got myself horribly confused. For I in range len r minus 2, -1, -1. See, I don't want that +1 there, do I? J equals I plus 1, while Rj is greater than Ri. New is equal to min after J. If new is equal to J, break J equals new. Min after I equals J. Same logic, except we're working up rather than down. Go, I hope that's correct. I really do wonder if this should not be pointing to 0, but should in fact be pointing to itself. So here, I've got this logic horribly mucked up, and I don't even know what I'm going to do with it. Because now I know this thing has the full bounds, in theory. In theory, min before 1 and min after 1 are 0 and 3. But how does that help me? Oh, well, actually, does it help me? This goes from 0 to 1. No, in fact, this would be 0 and 4, I think. Anyway, this goes from 0 to 1. And I know there's exactly one way of doing that. This one goes from 0 to 4. And I know there's 1, 2... no, that's not going to help. No, I need the number of sets in that range over that distance that will contain this element. So that's 1, 2, 3, 4, 5, 6. That's hard to count, though. How can I count that a priori? So the easy ones are ones like this. That'll be occurring once, that'll be occurring once. This one here is in these two. So that'll be occurring once, and there again. Hang on, so what I want to do is for I in range len r, print min before I, min after I. And use the example test cases. So here I get 0, 0, 1. That's expected. 0, 0, 1. 0. Oh, sorry, no. I'm looking, the thing before it is the 0. I'm looking at the 0, and it's bounded above by 1. So it's a 0, 1 interval. Here I'm looking at the 1, so it goes from 0 through to... I want to include that, though, so that'd be quite nice. I'm looking at the 2, goes from 1 up to 3. Maybe this needs to be a -1. And maybe this needs to be a len r. What does that do for me? Yeah, it's out of range, so that was completely the wrong thing to do. But it's doing something close. It's kind of doing what I want. The 3, I know this is lower. What do I want to do here? Well, this is less than this. No, that's not right. J is equal to I minus 1. J is equal to I. No, that's not what I want either. This is almost right, but it's not quite right. This should really be a... This should kind of be a 0, shouldn't it? So for the 2, I want that to be 1 and 3. That's correct. For the 3, I want it to be 3 and 3. It's not what I want. Well, let's have a look for the second one. Hang on. For 0, it's the minimum thing. 0, 1, 2, 3, 4. So the problem is it's ambiguous as to whether it's exclusive or inclusive. So while this is telling me, hang on, let's go with prev is equal to I. Prev equals j, j equals new. I'm going to keep going until I hit prev. So let's do this here. Prev is equal to I. Prev is equal to j, and this is equal to previous. Let's run that. Does this trailing II is not defined? My keyboard is still doing its weird double typing. I'm not signed in. That's obviously not correct. One should be going from 0. Well, Ri is greater than... Rj is greater than Ri. 3 is greater than 1. So what we want to do is we want to look at min before, which is 0. If 0 equals 0, break. Bollocks. At this point, I feel like I'm making random permutations, which is not the way you should go about solving these problems, but I'm a bit stuck. There's some boundary condition that I don't quite understand how to solve. Let's try this. Zero, 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 0, 1, 3, 0 through 3, yes. 2 to 3, yes. 3. Oh, thank goodness! I think that actually worked. 0 to 2, is that correct? 0, 1, 2. No, that's not correct. That should be a 3. Why did... No, in fact, it should be a 4. 0, 1, 2, 3, 4. 0, 1, 2, 3. That one's correct. That one's correct. That one is correct. That one is incorrect. Why are they breaking? That's not clear to me. The first one seems to be working. 0 is all bound by itself. 1 goes from 0 through to 3. You're not helping with your automatic selections. 2 goes from 2 to 3. Yes. And 3 is just by itself. Yes. So that one works. This one here. So 0, 1, 2. That one doesn't work. Why not? So it counts up, that's fine. 0, 1, 2. So 2, it says it goes to 2. Oh. That's why it doesn't work. So here, this one sort of is a valley. Here, it's a hill. My logic works for the valleys, but not for the hills. Okay, let's try simpler logic. While j is greater than or equal to 0, and all of that business. Let's just do that. While j is less than the length of the array, and all of that business. J equals j plus 1. Right. Zeros work, 1 works, 2 works, 3 works. So this one here, 0, 0, 1, 2, 3. Yes, that works. 1 is yes. Yes, that works. 2, yes. In fact, hang on. Yeah, no, that's fine. 3. Goes there to itself. Yes, that's correct. Everything outside those is less than it. This one here extends 0, 1, 2, 3, 4. Whew. Okay. So now I have this rather interesting list. It is quadratic, unfortunately, which is not very helpful, but hopefully it's something. Now what I want to do is I want to work out how many sets are there that go from 0 to 0, including itself. Well, we know that one's always at least included. The range is equal to min after I minus min before I. Actually, maybe I can make this count slightly easier. All the sets left of it, there are 2 elements. So that's 1 plus 2. All the sets to the right of it, that's 1, 2, 3. I need to discount those singles and I counted twice. Oh god, this is hard. Actually, no, let's count this another way. How many sets are there over 4 elements? We know there are 10. Sorry, subarrays. But we lose 1 for the one on this side. We lose 1, 2, 3 for the 2 on this side. So we lose 4 altogether, which gives us 6. So we have the total is equal to min after. Hang on. Let's do the range. How many elements are there? That's min after I minus min before I plus 1. Let's call that R. So So the total is equal to r times r plus 1 over 2. I can do an integer division because one of these will be even. On the range on the left is I minus min after, min before I plus 1. The left is RL times RL plus 1 integer division 2. And the range on the right is min after I minus I plus 1. Right is equal to RR times RR plus 1. Integer division 2. Print total minus left minus right. So this tells us, whoa, what? Oh, we don't want the plus ones there because we want to be exclusive of the middle. So there's one thing with a 3 in it, 6 things with a 1 in it, 2 things with a 2 in it, and 1 thing with a 4 in it. Holy moly, I think that's correct. So, I want to do, in fact, let's call that T. Total is total plus T minus left minus right times Ri modulo M. Whew. Yes. Ah, God, that's a hard one. I'm still worried because these, it's still quadratic, basically. But hopefully these are short enough that it's not a problem. I don't know. I'm going to use these bigger cases. We're fast enough for that one. Here's the big test. Wrong answer. Jesus. That's a problem. Trying to be clever has gone and sunk me. How did... Oh my god. Jeez. 1, 4, 2, 6, 7, 1, 0. No, can't have a 0 in it. 7, 7, 7, 7, 7. Now I'm just sort of trying random things to see if I can make it break. Good, it broke. Right, why did it break here? Is it the duplicate? What happens if I remove those? Is it still broken? Yes. If I remove that, is it still broken? Yes. So it should be 1. Hang on. Let's print out Ri and are from min before I to min after I plus 1. So this is 1, 4, 2. So that covers all of those. Oh, it's because of this. This 1. No, hang on, what's going on here? So this is correct, it'll be the minimum for these. The 4 will be the minimum for itself. The 2 will be the minimum for those. And the 1 will be the minimum over... It won't be the minimum over those, though. So 1 plus 4 plus 2 plus 1 is equal to 8 plus 1, 9, 11, 12, 13, 14, 15. Did I just never do... One of these just never ranged over the whole thing. So maybe one of these, one side of it needs to be equal. Yeah, maybe that's it. Why did I lose that one? I've lost the test case that I got wrong. Ah! I guess we're going to have to submit again without the print statement. We don't need that junk anymore either. Or any of that. That was, well, kind of right actually. But anyway. That doesn't seem good. Time limit exceeded. It's this. Needs to be able to jump faster. So I don't want to do a j minus 1. What I want to do is min before j new is equal to, in fact, new, it's just j is equal, if j is equal to previous, break. Don't know if that's correct or not. Because there's something here about when we reach the maximum. We get into a little loop of it staring at itself. Because there's nothing for it to hit. Oh, I don't know. Something funky is happening here with this jumping. So hang on. Print I min before. So that's kind of correct. That 0 is always correct. This one here, the min before. Hang on. Let's put that after so I can see what it got set to. So this, we start here. Thing before that's minimum, well, no matter which way it moves, it goes down, so it can't move. Looking at 1. This one here, it can move this way, so that's correct. This one here, it can move all the way up there. That's correct. In fact, should it be able to go even one further? Maybe. If I change that condition, what actually happens? Nothing. It's because of this 0 case. This 0 is causing problems. Hang on. Does that do better? None of this is moving. We got closer. Let's set those to be equal. That's better. That made it all the way back now. But I am worried we're relying on this too much. Give me the big case. Yes. In fact, let's use the example test cases first. Yes, let's remove the print. Big one. I am not signed in. Good God, this is annoying. They need to sort out that bug. Right, let's try again. Let's not go too quickly, maybe that's the problem. Yes! Oh my goodness. Light, let's see. Light? Right. Let's see if it works. Oh, thank God. I'm strongly suspicious this is not the way to do it. So we've got some weird jumping to try and find basically the valley. So if it's a hilltop, obviously it's a narrow valley. And if it's a valley, it expands the whole thing. So that's what these two are doing. That's pretty gross. I don't love that. But we've had to speed it up with this jumping as well. That jumping makes the logic very complicated. And this check here, what this check is trying to do is if we're trying to detect if we've got into a cycle, because sometimes something might be bounded by itself, because if it is a hilltop, that's bad. But if we can still move, then we need to keep moving. So this sort of forces us over hills. Oh, geez. Perhaps some sort of... they're not in order. I was going to say some binary search, but that if they're jagged hills, it doesn't help us. This guy here is just the cycle check. And then this here, now this is actually kind of clever. I don't mind this. This is us trying to count how many, what's the word for this? How many subarrays there are between two indices, inclusive, that also include some middle index that's between them. So that's quite neat. That's a neat little bit of maths to do that. Anyway, what a beastly problem. that one was really hard. I guess we get that after some easier ones the last couple of days, although we had a nasty one earlier in the week as well. Well, no, I made it a tricky one. I don't know if it was actually a tricky one. Anyway, that's it from me. Do let me know how you got on. If there's a better way to do this, I would absolutely love to hear it. Remember to like, comment, subscribe, all of that good things. Have a wonderful weekend. If you're in the US and have just celebrated Thanksgiving, I hope you had a wonderful time. And now we're entering the Christmas period, so yay, the stores are all filled with Christmas stuff, and we're not even in December. Anyway, I will see you next time.